See, we have already covered resistance in series and resistance in parallel. So moving forward, now we will study combination of series and parallel and how to find equivalent resistance when there are many resistances which are connected in series, parallel, or combination of both series and parallel. So we'll move forward. Okay, so now we have to find out whether two resistances or more resistances are in series or not. Suppose we have two resistances R1 and R2. Now if you will see that if some current enters R1 resistance, it will come out from R1 and will directly enter R2. There are no other connections between R1 and R2 where the current can go. So in series, the current through both the resistance will be same, and two resistances are said to be connected in series if there is no wire connection between them except the wire which is joining R1 and R2. So R1 and R2 are connected in series. Now coming to this figure. Suppose some current enters R1, it will come outside of R1. Now the current can go in the upper line also and in the bottom line also. Now at this point, see, now there is a connection between R1 and R4, this red wire. So R1 and R4 cannot be in series. Similarly, R1 and R2 can also cannot be in series because between R1 and R2 there is this R4 connection. So now if after this point some current will go in R2, will exit from R2 and will enter R3. Now there are no other connection between R2 and R3 except the wire joining them. So R2 and R3 are in series. So this is the way you have to find out whether the resistance are in series or not. Coming to this figure. Suppose current enters R1, will exit R1 and there are now two wires. So one part of current will go in R2 in the upper line and one will go in R4 in the bottom line. Now between R1 and R4 there is a connection. So R1 and R4 are not in series. Between R1 and R2 there is a connection. So R1 and R2 are not in series. But if you will see, if some current, suppose 2 ampere enters R2, it will exit from R2 and the same 2 ampere will enter R3. So R2 and R3 are in series. Similarly, some current will come from here, some will here, some come from here and will combine. So the current that will enter R5 will exit R5 and then enter R6. So R5 and R6 are again connected in series. So this is a way to find out whether your resistances are connected in series or not. So moving further, let us discuss how to check if resistances are in parallel or not. Suppose we have two resistances R1 and R2. Put a point A on the left side of R1 and a point B on right side of R1. Now from this point to this point, see there are no resistance in these 2 points. There is no battery between these 2 points. There is no switch between these 2 points. So if this point is A, then this point will be A. Similarly, if this point is B, then from this point to this point there are no resistance, no battery, no switch. So this point will also be B. So on the left hand side of R1 the point is A, on right hand side B. On left hand side of R2 the point is A, on right hand side B. So point across both the resistance is same, so they are connected in parallel. You can directly check from the figure also. So they are not in series, but this is a convenient way to check if they are in parallel or not. So there's a complex circuit now here. There is R1, there is R2, there is R3, there is R4. Now I have to check whether any of combination is in parallel or not. So let us check R1. So on one side put A, on another side put B. So if this point is A, then from this point to this point there are no resistance, no battery, no switch. So this point will be A. Now this point will be B, but coming from here to this point there is a resistance in between. So this point is C, but again this point will also be C because there is nothing between these 2 points. So across R1, see we have A and B. Across R2, check. Across R2 there is A and C, A and C. Across R3 there are A and C, A and C, and across R4 the points are B and C. So if you'll see, R3 and R2 are in series. So for complex circuits, this is a way to check whether resistances are in parallel or not. This method will be very helpful to check to solve questions of MCQ. Okay, now here's a numerical. Now we have 2 ohm, 2 ohm, then another 2 ohm, 2 ohm and 2 ohm. So there are 5 2 ohm connected in a circuit like this. Now I have to find out the equivalent resistance. First see, this 2 ohm and 2 ohm are in series. Now be sure about that. So this 2 ohm and 2 ohm are in series and this 2 ohm and 2 ohm are in parallel. So we'll solve this separately. So equivalent of both of them will be 4 ohm. We'll solve both of this separately. So equivalent of this will be 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2. So first resistance is 2, second is also 2. Putting the values 2 and 2. So after solving this, the R equivalent comes out to be 1 ohm. This R equivalent is for this 2. This R equivalent is for this 2. So we will shorten the circuit. So at the place of this 2 and 2 ohm, we will put 4 ohm. On the place of this 2 ohm and 2 ohm, we'll put 1 ohm and this 2 ohm will be here. Now if you can see, the current that will enter 4 will come out of 4 and enter 1, and the current that will come out of 1 will enter 2. So there are no other connections except the wire between 4, 1 and 2. So all these three will be in series. So the answer will be 4 plus 1 plus 2. The answer will be 7 ohm. So on the basis of this video, you have to solve an online quiz that is there with this message from where you're getting this message, or you can also check the description of this video. The online quiz is there. If you have any doubt, you can WhatsApp me on my number or you can call me up. Okay.